Mhm. Lecture number 2, the basic organization of computer. So, in this lecture, you will learn about the basic of computer system organization, computer abstractions, how computer's main memory is organized, and types of araylankurdu. How computer's main memory is organized and the types of instructions for a typical processes. Um, so a brief review of computer history. Mhm. So, in this historical epoch, computers were first developed by the Egyptians, who had the abacus in the pre-industrial era. Do you know what is abacus? Hmm? Abacus. Okay. And in the pre-industrial era, mechanical calculators were developed by Pascal and Leibniz. During the Industrial Revolution, mechanical computers were envisioned and parts of such machines were prototyped by Charles Babbage. These computers were not constructed in their entirety due to the size, weight, and power requirements that couldn't be satisfied by the technology of the day. Uh, Hermann Hollerith. Hermann Hollerith. Have you ever heard about this um, inventor? With the discovery of electricity,
Don't
okay. Uh, so with the discovery of electricity and electronic tabulating machines were developed by Herman Halleris, whose company was purchased by Thomas Watson, a founder of the IBM, International Business Machines Corporation. So Herman Halleris was an American businessman, inventor who developed an electromechanical tabulating machine for punched cards. Punched cards at the perfocarton to assist in summarizing information and later in accounting. Так, ENIAC and the Mark I. The advent of World War II increased the demand for more accurate calculations. Rooms full of humans were employed in computing artillery trajectories, and the result was unacceptable error. A variety of computing research projects were undertaken at Princeton University, Harvard University, and the University of Pennsylvania. This resulted in room-sized computers such as the Mark I through Mark IV and the ENIAC, all of which used vacuum tubes. Do you remember what is vacuum tubes?
системный как сервер.
Vacuum tubes, электронные лампы, да? The vacuum tube machines were erroneous tubes burned out or their response drifted frequently. Power intensive, slow, то есть less than 10,000 integer multiplications per second, and hard to program, but provided a useful testbeds for basic computers, computer concept. Overview of computer abstractions. Mm, as shown in figure 1, computer system divided into operating system, assembler, instruction set architecture, and processor memory and the input-output system, data path, and control. So here's operating system provides a convenient interface between the user and the application software and the hardware. Assembler translates assembler languages, a primitive type of programming language, into machine code, which is stream of one and the zeros. Next is abstraction set architecture. Instruction set architecture interfaces the software to the hardware. So it's least above to least below, yeah, and it provides support for programming. Next step is processor, memory, and input-output system. This component supports the execution of machine code instruction expressed in terms of the input instruction set architecture, ISA. Data path and control provides a convenient abstraction for connecting the processor, memory, and the input-output system and controlling their function efficiently. Computer system abstractions span many levels of detail, which in computer science we call levels of abstractions. And the other type of different abstract views. So abstractions help us express intangible concepts in visual representations that can be manipulated. For example, a data structure is an abstraction that organizes concepts or numbers in a comprehensible, organized representation that can be manipulated by a computer program. Also, in this picture illustrated another view of computer system, which is comprised of different levels of languages and the means of translating these languages into low-level languages. Finally, the microprogram is loaded onto the hardware. So here is from level 0 to level 5. The talent concepts for figure 2 are listed as follows. Level 0, или digital logics, yeah, or we call digital logic. The circuitry that makes a digital computer run is called logic. All processes of a digital computer are expressed in terms of functions of ones and zeros, for example, and, or, and not functions. Логическая операция, and, or, not functions. Next level, microarchitectural level. Micro instructions are low-level control instructions that define the set of data path control signals which apply to a given state of computing machine. The micro instructions together with the sequencing and comprise the microarchitecture whose purpose is to rigorously and consistently express the control of logic circuits that complete the computer hardware. Designing this control in terms of a program that implements machine instructions in terms of simple and micro instructions is called microprogramming. Next, please. Instruction set architecture. Nargisa, please turn off your microphone. One of the most important parts of a computer is the interface between the lowest level software and the hardware. The instruction set architecture includes anything programmers use to make a binary machine languages program work correctly, including instructions, input, output, and etc. This architecture facilitates design of functionality independent of the hardware. So next level, operating system machine, provides a convenient interface between assembly languages and abstraction of the hardware architectures instruction sets. Operating systems generally contain many libraries that help a software developer or programmer connect to lower-level system functions in an organized way. For example, input, output, memory allocation, etc. Level 4, fourth level, assembly languages. Assembly is a very detailed language that helps the system programmer or software designer move information around in a computer architecture in a highly specific way. For example, many compilers, компиляторы. Что такое компилятор? Маргиза қайтадан шығып кіріп отыр. What is compiler, компилятор? Что такое компилятор? Компилятор деген не? Да?
Yes, sorry, teacher. Yeah.
Если тұрған жоқ. Do you hear me?
Yes, I'm here. Sorry.
So what is compiler? Что такое компилятор, уважаемые студенты?
Пишем код.
Ау?
The place where we
Это программа,
Right.
которая преобразует тексты в код.
Нет, это, ну, где мы пишем код, по идее. Онлайн.
Да, он переводит на язык, который понятен компьютеру. В общем.
Translate programming languages into assembly like
Компиляторы.
computer languages. Okay, so for example, many compilers are written in assembly languages. The advantage to assembly language is speed and the power in accessing various features of the hardware. Compiler divided into two groups, yeah? Translators and the трансляторы и что? Что такое транслятор? Сіздер бірінші курста қандай сабақ оқыдыңыздар? Неге байланысты? Транслятор, компилятор, интерпретатор деген өттіңіздер ме? Программирование кірді иә сіздерге?
Программирование өттік, C#.
You heard about translate and the interpretator and the translator. Okay. So next step, level 5, problem-oriented languages. Provides a convenient interface and applications engine that helps the user produce results specific to a given application area. For example, Microsoft Word is used for document creation or creating, Excel for accounting, spreadsheets as электронные таблицы. Yeah? The languages at this level is usually a sequence of keys strokes, or high-level scripting languages. In software design, the language is high-level programming languages such as which programming language we can include to high level? Қандай programming language'дерді біз high level жоғарғы деңгейде уровеньге жатқызамыз?
Yes.
How?
Yes. Python.
Yeah.
Қай уровеньдағы программа тілдерін білесіз бе?
Жоғарғы уровеньдағы қандай программалық тілдерін білесіздер?
C++.
Pascal.
Java and
Pascal
Python.
бар.
Pascal.
C++.
Okay, thank you. Так, next. Basic organization of a computer system. So, any computer can perform the four basic operations, yeah? For example, inputs, processing, output, and then storage. Operations. This figure displays all the functional units of a computer which carry out the basic computer operations. The lines in the figure indicated the flow of instructions and the data, while the control unit and the arithmetic logical unit together direct the flow of control. Control in the central processing unit. Central processing unit. Central processing unit manages the instruction execution cycle. For example, teach, decode, execute, and coordinates the activities of other devices. So main memory, storage device for preserving binary data and instructions. Memory is divided into units or words. Each is usually a standard size of fixed length. Each memory word has a unique address or random access. Random access memory, read-only memory. What is the difference between random access memory and read-only memory? How do you think? How do you think? What's the difference between random access memory and read-only memory?
Yeah.
RAM memory is fast.
Так, кім сөйлеп жатыр? Елжас па? Айта ғой.
Yeah. Если так объяснять, то RAM это временная память, а ROM это получается, ну, точнее, RAM это быстрая память, считывая информации, объем данных, ОЗУ, либо же, ROM это объем накопительная память.
Постоянно запоминающее устройство — это оперативно запоминающее устройство, да? Okay, thank you. So, random access memory, readable, writable, usually volatile, and general storage. Read-only memory, also readable, permanent, non-volatile, and special purpose storage for data and instruction. The next is the central process unit and the main memory. The actual processing of the data is carried out the central processing unit, which is the brain of computer. This SPU stores the data and the instructions in the primary memory of the computer, called the random access memory, and processes them from the location. The arithmetic logic unit and the control unit are the two subcomponents of the SPU. The arithmetic logic unit carries out the arithmetic and logical operations, while the control unit retrieves the information from the storage unit and interprets this information. The SPU also consists of circuitry device called cache and the registers. Arithmetic logic units, the data and instructions stored in the RAM are transferred to arithmetic logic unit for processing. This unit performs the logical and arithmetic operations on the data, and the results are temporarily stored in the RAM. After the processing, the final results are stored in the secondary memory. The storage units and their ender are released through an output device. Inside the central process unit, memory address register, memory data register, instruction register, program counter, accumulator, system clock, arithmetic logic unit. Fetch the instruction. First, address of the next instruction is transferred from PC to MAR. MAR here is memory address, which is the the instruction is located in memory. So first, address of the next instruction is transferred from PC to MAR. Then the instruction is located in memory, and the instruction is copied from memory to MZR. MZR is here, memory data register. Decode the instruction. Instruction is transferred to and decodes in IR. IR is here, instruction register. Execute the instruction. Control unit sends signals to appropriate device to cause execution of the instruction. So that's all for today. The basic organization of computers. Now, here's questions to seminar. You should find out more information about Abacus Friendship Card with Abacus или счеты, да? Short collection. Friendship cards, перфокарты, вот из Abacus with Friendship cards,